In this lesson, we shall perform a simple fuel load calculation to consolidate what we have covered in the last two lessons. For this, you will require a CRP5 and possibly an electronic calculator. At each break, complete the calculation for that part before moving on. Use the following fuel figures: taxi fuel 5 gallons, climb fuel 15 gallons, descent fuel 7 gallons, cruise 50 gallons per hour, alternate fuel 20 gallons, endurance speed 40 gallons per hour. The following information is also required. Top of climb to top of descent is 180 nautical miles at flight level 55. Outside air temperature plus 12 degrees Celsius. Indicated airspeed 140 knots. Track 060 degrees true. Wind velocity 010 degrees at 20 knots. Assuming contingency fuel is not used, calculate the fuel remaining at the destination. We will go through this step by step, so take note of the information given and go straight to the next part. We can start the calculation by filling in those figures which need no further interpretation. We have been given the fuel required for the climb and descent, so to complete the trip fuel, we need to calculate the fuel from top of climb to top of descent. Using the CRP5, 140 knots indicated airspeed at flight level 55 and outside air temperature plus 12 degrees gives us a true airspeed of 154 knots. Using the calculated true airspeed, true track and wind velocity, we have 6 degrees starboard drift and a ground speed of 140 knots. 180 nautical miles at 140 knots ground speed gives a time of 77.2 minutes. 77.2 minutes at fuel consumption of 50 gallons per hour equals 64.3 gallons of fuel burned. If we now add the fuel for the climb and descent, the resultant is the trip fuel of 86.3 gallons. Contingency fuel is 5% of the trip fuel. Therefore, contingency fuel is 5% of 86.3, which is 4.3 gallons. We now have to add the final reserve fuel, which, for a piston engine aircraft, is 45 minutes flying time at endurance speed. In this case, at endurance speed the aircraft uses 40 gallons per hour, therefore, in 45 minutes it will use 30 gallons. If we add all the figures, we have the fuel uplift at departure. To calculate the fuel load at the destination, assuming we did not use the contingency fuel, subtract the taxi and trip fuel of 91.3 gallons from the total uplift. The answer is 54.3 gallons. The method of calculation just described holds good for all the various questions you may get in the exam. The major difference between piston and turbine-powered aircraft is the time used to calculate the final reserve fuel. The turbine-powered or jet aircraft final reserve is calculated on the basis of holding overhead the destination or alternate airfield at 1500 feet for 30 minutes. However, for examination purposes only, assume the final reserve is based on holding over the alternate airfield specifically. The figures used for most fuel load calculations are taken from the CAP 697, which will be explained in later lessons. Unless instructed otherwise, contingency fuel is calculated as 5% of the trip fuel. Final reserve fuel for piston aircraft is fuel for 45 minutes at endurance speed. Final reserve fuel for turbine-powered aircraft is the fuel to hold at 1500 feet above the destination or alternate for 30 minutes. In exam questions, the contingency fuel may or may not have been used. Read the questions carefully.